Welcome to the final video in an introduction to machine learning. We've previously compared our machine learning models. Now it's time to apply to experimental data. So you may have been asking throughout, what about real experimental data? And you may also be asking, are we there yet? So we're going to check that our machine learning models behave similarly with real experimental data and then finish. So notice that we've trained and tested our machine learning models on simulated data for signal and background. That's why they were definite labels Y. This has been a case of supervised learning. Your machine learning models would then be applied to real experimental data. To make sure our models make sense, we should check whether simulated data and real experimental data have the same shape in classifier threshold values. We first need to get the real experimental data. We've got a challenge for you to end all challenges. Number one is to read data.csv like in the data discussion lesson. Data.csv is in the same file folder as the files we've used so far. Then part two is to apply cut-lep type and cut-lep charge like in the data discussion lesson. Part three is to convert the data into a NumPy array, xdata, similar to the data pre-processing lesson. You may find the attribute .values useful to convert the pandas data frame to a NumPy array, or there are other ways to do it as well. Part four, don't forget to transform using the scaler, like in the data pre-processing lesson. Call the scaled data xdata scaled. And part five, predict the labels your random forest classifier would assign to xdata scaled, and call your predictions ydata_rf. So pause the video and work that out yourself. If you need the answer to part one to move on to part two, then remember you can just click here. So in part one, we read the CSV file. In part two, we applied cut-lep type and cut-lep charge. We didn't need to define these since they were already defined earlier in the lesson. Then we get the data frame, only the variables which correspond to the machine learning inputs, and then turn this into a NumPy array using .values. Then we use the scaler that we fitted earlier to transform xdata, and then predict the labels on xdata using our random forest. Now we can overlay the real experimental data on the simulated data. On the x-axis is threshold, in blue is background, orange signal, and in the green bars is data. And within error bars, the simulated data histograms agree with the experimental data error bars. That's great news. Our random forest classifier model makes sense with real experimental data. So at the end of the day, you might want to ask, how many signal events is the random forest classifier predicting? Do that with these. And what about background? So our random forest classifier is predicting how many real data events are signal and how many are background. I think that's pretty cool. So that's it. You're now ready to machine learn to take over the world. Hopefully you've enjoyed this brief discussion on machine learning. Try playing around with the hyperparameters of your random forest and neural network classifiers, such as number of hidden layers and neurons, and see how they affect the results of your classifiers. Thanks very much.